A grainy, unremarkable patch of Saturn's cloud tops fills the frame, swirling bands of pale gold and muted brown. It looks like a routine weather snapshot, except it is not. This is the final photograph Cassini ever took, captured at an altitude of just 3,900 kilometers on September 14, 2017. Moments later, the signal cuts. The spacecraft does not drift away. It plunges directly into the atmosphere of the gas giant, becoming part of the planet it studied for 13 years. But this is not a surrender. It is a final, controlled act of protection. After 2 decades in space and 13 years revolutionizing our understanding of Saturn, the Cassini spacecraft has one last command to obey. Mission controllers steer it deliberately toward destruction. This is the grand finale. The reason is not a malfunction or a lack of fuel, but a profound ethical duty. Cassini's own discoveries revealed that moons like Enceladus and Titan possess the ingredients for life: global oceans under icy shells, organic chemistry, potential energy sources. A dead, drifting spacecraft could one day crash into and contaminate these pristine worlds. To preserve them for future exploration, Cassini must be removed. So, in its final months, it is sent on 22 daring weekly dives through the narrow, unexplored gap between Saturn and its rings, a region no human-made object has ever entered. These are not just victory laps. They are a final reconnaissance, gathering shocking data until the last possible second. And then, on September 15, 2017, that data stream will turn into a final, fiery beacon. The grand finale is a suicide mission, by design, to protect the very possibility of life elsewhere. It is a spacecraft sacrificing itself for the secrets it helped to unveil. For 13 years, Cassini has drawn a careful map of the Saturn system, but one region remains a blank, a void. A narrow band of absolute uncertainty, roughly 2,400 kilometers wide, sitting directly between the planet's swirling cloud tops and the innermost edge of its D-ring. No spacecraft has ever crossed it. The risk was always deemed too great. Even a single grain of ring material moving at orbital velocities could shred Cassini's delicate instruments or knock it completely off course. This is the unseen gap. Mission planners call it the region between the rings and the planet. For all of Cassini's 13 years in orbit, every trajectory has deliberately skirted this zone. They simply did not know what lurked inside. Was it a shooting gallery of debris, a silent, empty canyon? The unknown was too dangerous to gamble $1 billion spacecraft on. Now that gamble is the only path forward. The grand finale demands 22 consecutive dives directly through this uncharted space. Each pass will take Cassini screaming between Saturn's atmosphere and the rings at over 110,000 kilometers per hour. For the first plunge and a few later dives, the spacecraft turned its high-gain antenna forward as a makeshift shield, severing contact at the most critical moments. It must fly blind, collect its data in isolation, and then re-establish communication on the far side if it survives. The first dive is not a scientific curiosity. It is a crossing into the one place the mission was never allowed to go. A deliberate breach of the last unexplored threshold, the moment of truth. For the first time in history, a human-made object is about to fly through the space between Saturn and its rings. Mission controllers at the Jet Propulsion Laboratory hold their breath. All their models predicted this region would be filled with dust and ice. A potentially lethal environment moving at over 70,000 miles per hour. Even a particle the size of a grain of sand could be catastrophic. They have oriented Cassini's large, dish-shaped high-gain antenna forward, using it as a makeshift shield. The spacecraft is utterly blind, its cameras turned away from the danger. All they can do is wait and listen. Then, the data arrives. The plasma wave instrument, designed to hear the pings of dust impacts, transmits its findings. Instead of a constant, deafening roar of collisions, there is almost nothing. An eerie, profound silence. The gap is not just clear, it is strangely, almost impossibly, empty. The ring particles simply aren't there. In this first daring plunge, the feared hailstorm never materializes. The void is quieter than anyone dreamed, raising an immediate and profound question. If the gap is so empty, where is the ring material actually going? The quiet is the shock. The gap between Saturn and its rings, the unexplored frontier Cassini is now traversing, was predicted to be a dangerous, dusty haze. Models suggested a cloud of fine particles, a navigational threat. Instead, the spacecraft's instruments report a startling clarity. The void is almost empty. The predicted dust, the expected steady rain of ring material into the planet's atmosphere here, is simply not present. This single clean pass forces an immediate and fundamental rethink. If the rings are not steadily shedding this fine material directly into this gap, then the entire model of material transfer is wrong. The question becomes urgent and specific. Where is the material going? The emptiness suggests the rings are more sharply defined than anyone thought, that their edge is a hard boundary. It means the process of ring material eventually spiraling down into Saturn's atmosphere is not a simple, gentle drift. This discovery points to a more violent, more punctuated, and entirely different mechanism. The quiet gap is now a loud problem for planetary scientists. It demands a new explanation for the life cycle of the rings themselves, pushing theory into uncharted territory to account for this profound and unexpected silence. But the silence of the gap is not the only shock. As Cassini hurtles through the narrow void, its cosmic dust analyzer begins to register impacts. The instrument is designed to catch microscopic grains, but now it is overwhelmed. A rain of debris is pounding the spacecraft from above. This is not a gentle mist. The analyzer measures a staggering flux, roughly 10,000 kilograms of material falling into Saturn's atmosphere every single second. The particles are a gritty mix of water ice, silicates, and dark organic compounds, the exact ingredients of the rings. Pre-mission models had predicted a sparse drizzle, a slow erosion spread across billions of years. The data now screams a different story. The data now screams a different story. The rings are not a static, ancient crown. They are a temporary, brilliant storm. The instruments on Cassini's final dives measure a torrent. Ring particles are raining directly into Saturn's atmosphere far faster than anyone predicted. The rate is staggering, equivalent to about 10 cubic meters of water falling from the rings every single second. This is a cascade of destruction. The iconic rings are actively losing mass. They are being stripped away. This intense ring rain means the rings are not a permanent feature of Saturn. They are a fleeting spectacle in the planet's long life. Based on this ferocious loss rate, scientists calculate a shocking new timeline. The entire ring system could vanish in roughly 100 million years. That is a blink in cosmic time. This implies the rings are astronomically young. They likely formed less than 100 million years ago, perhaps from a shattered moon or comet. They were not present when dinosaurs walked the Earth. Saturn's greatest glory is a recent arrival and is already dying. We are witnessing its slow, beautiful demise. The very act of observing it reveals its impermanence. But the grand finale reveals a second, more fundamental mystery, one that goes to the very heart of the planet. How long is a day on Saturn? We still do not know. Unlike Jupiter, Saturn lacks obvious surface features to track. Its rotation is hidden deep within. For decades, scientists used its magnetic field as a proxy, assuming the field's tilt would reveal the planet's spin. But Cassini's final, close-in measurements during these dives deliver a shocking result. Saturn's magnetic field is almost perfectly aligned with its rotation axis. There is no significant tilt. It is an astronomical oddity that makes pinpointing the true rotation rate from the outside nearly impossible. The planet's inner rhythms are locked away, guarded by this bizarrely symmetrical magnetic shield. As Cassini plunges repeatedly through this unexplored region, its instruments strain to detect any subtle wobble, any hidden signature in the magnetic data that could finally answer the question. It is a last, direct probe into Saturn's interior, a final attempt to hear the heartbeat of a giant that has, for centuries, kept the length of its own day a perfect secret. The magnetometer aboard Cassini is now sampling Saturn's magnetic field from closer than ever before. Every orbit through the gap brings the spacecraft deep into the planet's magnetic cocoon. What it detects is not the expected rhythmic pulse of a tilted dynamo. Earth's magnetic axis is offset from its rotation axis by about 11 degrees, a skew that generates a clear, repeating signal. That signal is how we measure the exact length of our own day deep inside the core. But here, inside Saturn's magnetic cavity, the signal is a flat line. The internal field is aligned with the rotation axis to within 0.06 degrees, an almost perfect symmetry. There is no detectable wobble, no periodic swing. The radio emissions that once hinted at a rotation period turn out to be shifting, unreliable, a flickering mask rather than a steady clock. Mission scientists had hoped that the grand finale orbits would finally reveal a hidden tilt, some subtle asymmetry buried in the noise. Instead, the precision data confirms the opposite. The dynamo churning deep within Saturn is so precisely aligned that the true length of a Saturnian day remains unreadable. This is not just an inconvenience. It means the fundamental mechanism generating Saturn's magnetic field is fundamentally different from Earth's. The conducting metallic hydrogen shell rotates without the turbulent misalignment that defines our planet's geodynamo. Cassini's magnetometer records a field so symmetrical that it challenges existing models. The spacecraft listens for the heartbeat of a giant, but the magnetic field offers only a puzzling, near-perfect alignment. The secret it has guarded for centuries is now proven to be locked away, not by distance, but by a perfect, almost unnatural alignment, a dynamo spinning in eerie silence. The signal shifts by less than a millimeter per second, a whisper against the roar of deep space. but every microscopic variation in Cassini's radio carrier wave maps the invisible architecture pressing against it. During each grand finale dive, the spacecraft's trajectory bends through Saturn's gravity field, and the Doppler shift in its transmission becomes a probe reaching straight into the planet's hidden layers. The science teams are not measuring a simple uniform sphere. They are feeling the ghost of motion thousands of kilometers below the cloud tops. The data reveals something deeply unsettling. Saturn's interior does not rotate as a single solid body. Instead, deep differential rotation persists far beyond the visible atmosphere, continuing down into regions where pressures reach millions of atmospheres. Here, hydrogen flows in distinct cylindrical shells, each shearing against its neighbor. The boundary between a fluid envelope and a discrete rocky core dissolves into a blur. No sharp transition exists. Gravity harmonics show a diffuse, extended core region where heavy elements mix gradually with metallic hydrogen over a zone nearly half the planet's radius. This means Saturn's heart is not a hard seed, but a smeared-out distribution of rock and ice, slowly dissolving into a churning electric ocean. The dynamo that powers the magnetic field operates within this slush, and the gravity data now forces theorists to explain how such a structure can produce the eerily perfect alignment Cassini already measured. The planet's deep hum grows stranger still. The giant is not just silent, it is structured to hide its rotation from the inside out. The sacrifice is now inevitable. Cassini's trajectory is locked. There is no longer any path that avoids the planet. This is not a malfunction, it is a deliberate, irreversible choice. The mission architects have drawn a final boundary around two moons, Enceladus, with its subsurface ocean and towering plumes, and Titan, with its methane lakes and thick organic haze. A dead spacecraft, even one sterilized before launch, could still carry dormant Earth microbes. Contamination is not a risk they will take, so Cassini must be destroyed atom by atom inside Saturn's atmosphere. The 22 proximal orbits have already threaded the needle between the rings and the cloud tops. Now the final 5 orbits push deeper, grazing the exosphere. Each pass bleeds a little more velocity. The navigation team calls it the goodbye kiss. On the last orbit, September 15, 2017, Cassini angles its high-gain antenna toward Earth one last time, a fixed stare locking onto the distant blue dot. The thrusters fire to keep the dish pointed as long as possible, knowing that within minutes aerodynamic forces will overwhelm them. The spacecraft is configured to stream back real-time data from 8 instruments, sampling the atmosphere's composition and magnetic field right up to the moment of disintegration. Every bit of telemetry is squeezed through the dying signal. The planet's hidden rotation, the strange magnetic alignment, the ring rain, everything still unknown depends on this final, sacrificial dive. The magnetic and gravity fields of Saturn's interior will have one last listener before the giant swallows the only witness that ever dared to whisper its secrets. The thrusters scream at full capacity, a desperate mechanical roar against the thickening atmosphere. Cassini's high-gain antenna, a fragile dish of white thermal blankets, strains to stay locked on Earth, a pinpoint 1.5 billion kilometers away. Every fraction of a degree of tilt means lost data, lost secrets. The spacecraft's reaction wheels spin, fighting the supersonic winds now battering its slender frame. Inside the nose cone, the ion and neutral mass spectrometer gulps molecules directly from Saturn's upper atmosphere for the very first time. It tastes hydrogen, helium, and traces of heavier compounds, volatiles that never condensed into the planet's deep interior. This is pristine stuff, a direct sample of the material that built the gas giant 4.6 billion years ago. No probe has ever breathed this air. Cassini transmits the composition in near real time, a stream of numbers that will rewrite models of planetary formation. At 100% thruster duty, the attitude control jets fire in a continuous blaze, pushing back against drag that grows exponentially. The spacecraft shudders, the signal strength flickers. Inside mission control at JPL, the telemetry screens paint a brutal portrait. Temperatures spike past design limits, the antenna wobbles by fractions of a degree, and the plasma density around the craft jumps tenfold in seconds. Still, Cassini holds on, its programming executing the final commands with unthinking precision. Then, the carrier lock vanishes. The waterfall display, a real-time graph of radio frequency power, drops to flat noise. The room falls silent. A single green spike on the screen, the last breath of a robotic explorer, fades to black. Saturn has claimed its closest robotic witness. The hum stops, leaving behind a quiet that is not emptiness, but a question finally answered. In mission control, engineers stare at a single, wavering trace on a screen. This is Cassini's heartbeat, a Doppler signal that has linked Earth to a robot 1.4 billion kilometers away for 2 decades. Now the curve bends. The spacecraft is no longer fighting. It begins to tumble, its high-gain antenna pushed off axis by a thickening atmosphere of hydrogen and helium. The signal flickers, then flattens. For a split second, the room is suspended in the time it takes light to cross that final gap. 83 minutes of delay between the event and its confirmation. But when the flat line holds, the truth arrives. Cassini has vaporized. No explosion, no fireball. Just a sudden dead radio silence where a stream of data used to live. Temperatures on the sapphire-strutted probe spiked past 500 degrees Celsius in seconds. The titanium hull softened, then dispersed into Saturn's upper clouds as a narrow, glowing streak, alien metal becoming alien weather. Every molecule of the spacecraft, every gram of its plutonium power source, now drifts in a hydrogen wind. The rings, which it dove through 22 times, continue their slow rain onto the planet. Nothing marks the spot. Only a quiet that is not emptiness, but a mission finally, irrevocably over. The witness is gone, its final whisper absorbed by the very world it was sent to decode. The silence that swallowed Cassini's final signal was an act of preservation. The spacecraft was destroyed to shield Enceladus and Titan, moons with subsurface oceans and organic chemistry, from any stray Earth microbes clinging to its frame. In that deliberate, violent end, a paradox now lives. The mission sacrificed itself for the possibility of life elsewhere, yet its last measurements reveal that Saturn's most iconic feature is itself a dying thing, far more fragile than we ever imagined. During the grand finale dives, Cassini's instruments sampled ring rain, a steady downpour of ice and dust cascading from the innermost D-ring into Saturn's upper atmosphere. The influx is staggering. Roughly 9,000 kilograms of ring material vanish every second, far faster than pre-mission models predicted. This torrent is not a slow leak, but a hemorrhaging. Extrapolating backward, the data suggests the rings may be as young as 100 million years, a blink in the 4.6 billion-year history of the solar system. They did not form with Saturn, they arrived late, and they are already leaving. The process is so aggressive that the entire ring system could erode into nothingness in another 100 million years. The dinosaurs never saw these rings. Future eyes looking through a telescope might see only a bare, beige planet. So the grand finale leaves us with a haunting symmetry. Cassini incinerated itself to safeguard distant cradles of potential life, vaporizing into the same atmosphere that is steadily drinking the rings to death. The witness is gone. Its legacy is a revelation of impermanence, written in the very vapor it became. And yet that ordinary patch of cloud, the last image Cassini ever captured, remains. It still churns in Saturn's upper atmosphere, a swirl of ammonia and hydrogen, indistinguishable from any other cloud deck. But hidden within its molecules are the atoms of the spacecraft itself. The titanium, the aluminum, the silicon chips, all vaporized, now part of the planet's eternal storms. The grand finale ended in fire, but it began with a gamble. 22 dives through a gap that turned out to be eerily empty. A void where ring particles should have been. That emptiness itself was a discovery, hinting that something, perhaps Saturn's magnetic field, was sweeping the region clean. The dives revealed ring material raining down at a rate of roughly 9,000 kilograms per second, far faster than predicted, forcing scientists to conclude the rings may be cosmic ephemera, perhaps only 100 million years old. They also measured a magnetic field so precisely aligned with the planet's rotation axis that the true length of a Saturnian day remains stubbornly hidden, locked in a core we cannot probe. The mission's final act was deliberate, a plunge to protect Enceladus and Titan from contamination. The spacecraft gave no final transmission, just a steady carrier signal that wobbled, then flatlined at 7:55 a.m. Eastern Time on September 15, 2017. The cloud tops swallowed the signal, and they keep swirling, unchanged, carrying the ashes of our machine in their silent, golden haze.